All right, what's good, everyone? We're gonna spend the very last section of class with a little introduction into multiple regression. And so the purpose of this is to just extend our simple linear regression model with one predictor that we talked about in the last section to allow for multiple predictors. And so the example that we're going to use first is we're going to stick with this first year GPA example where, if you remember, we've got some data on some students, and we talked about the description of it before, but it's from the Educational Testing Service. And we're treating this first year GPA variable as our response. And before, we were equipped to kind of maybe consider the high school GPA as a predictor, or maybe consider sex of the student as a predictor. But now we're going to start to consider a model with many of these predictors instead of just doing one at a time. And so we might have two goals when doing this. The first goal is more about hypothesis testing and confidence intervals for slope coefficients, and we're actually going to skip that goal just to kind of save a little bit of time. And we're only going to talk about goal number 2, which is if we were interested in building a model to predict the first year GPAs of students. And so this might be useful for people that work at a college or university to maybe understand what to expect approximately maybe from an incoming class. There's an article at the bottom of this that you could take a look at. It's kind of interesting and talks about some of the issues involved in actually using standardized testing in college admissions. But to answer this GPA question, we're going to start just with writing out what our population level model is for this example, as well as what our fitted model is. And so actually, before we jump down to the actual example, we're just going to write this in a more general way for any number of predictors, and we're going to think about there being maybe k predictors here. And so our model, you could see that we're just adding on to our simple linear regression model with more slope coefficients and more predictors all the way up to the kth predictor. So maybe k is 20 if you have 20 predictors, maybe k is 2 if you have 2 predictors, and etc. Our fitted model is also going to look really similar, except now, instead of just having one predictor, again, we're going to have k different slope coefficients and k different predictors in our model. You could see that the model was fit, and this table of output is given here, and you probably recognize a lot of the other stuff that we talked about before, like r squared is here. This table looks pretty similar with its p-values and its estimates. And we still have an intercept estimate, and so that stays the same. And now we've got a bunch of different slope estimates that correspond to the different predictors. And so each of these is attached to the same predictor in its row. And so our fitted model for this example, I'm just taking these estimated coefficients and multiplying by these various predictors. You might recall from the last section that sex is categorical, and so we actually need an indicator variable to define it, and it's defined up here. So it's a 1 if the student is male, a 0 if the student identifies as female. Treating gender as binary, or sex as binary here, because the data set collected only had 2 options here. Okay, and so from this equation, we could do similar prediction-y stuff as what we did before with simple linear regression. And so this is prompting us to find the residual for the first student in the data set. And so we could start by finding the predicted first-year GPA for that student. And the first student in the data set is here. So we have this nice little preview of the first 6 students, and we're just finding the prediction for this first one. And so it looks like this first student was male. So we'll start there. So male got the 1, so I'm going to plug in a 1 for that. We could grab his SAT math and SAT verbal scores, which were 62 and 65. So throwing those in for the next 2 parts. And we could grab his high school GPA, which was 3.4. All right, so again, prediction really isn't too bad for individual observations. You just kind of plug in the different values. If you calculated all that out, which I've done ahead of time, you would predict this student's first year GPA would be 2.89. But the question actually asks for the residual, which is the same definition as before. So it's the observed response minus what's predicted from the model. We see that his observed first-year GPA was 3.18. And so his residual is just 3.18 minus 2.89. So our model is under-predicting here. And in particular, it's under-predicting by 0.29 points. All right, so where we're going after this is, so we could do these predictions for each student in the data set, but who's to really say that this model with sex, these 2 SAT scores, and high school GPA is the best model for actually predicting first-year GPA? We might think that a model with maybe just SAT math and high school GPA might be better, or maybe a model with just high school GPA would be the best model. And so what we're going to talk about next is one way to determine what exactly might be considered best in terms of a model that is constructed for prediction of a particular response.